check out that book. But next, we have Dipankar Mizumdar, who is a developer advocate here at Dremio, with a presentation, How an Open Data Lakehouse Enables Data Mesh. Okay, Dipankar, the stage is yours.
Hey, Alex. Hi, everyone. I'm going to share my screen. Hope everyone can see it. All right. Hi, everyone. My name is Dipankar, and I'm a developer advocate at Dremio. Today, we are going to take a look at a topic, which is data mesh and open data lakehouse. And basically, we'll just try to understand how these two different things can benefit from each other, and also try to demystify a few things as we go. So how do organizations make the decision today? So for example, let's say you want to build some dashboards to understand historical trends in your product, right? And to do so with some kind of a centralized or monolithic architecture that we have in general, what we would do is we like to move the data from the operational sales system to some kind of a centralized repository like a data warehouse or like a data lake, right? But that requires, it's a tedious ELT and ETL process that might require specialized data engineers expertise. Also, this further impacts the downtime on the part of a data consumer. How many times we have waited for the data to be available to, do some reporting or build some models around that, right? So we definitely see some frictions with this type of centralized approaches. And that's why we have data mesh. But one of the main pain points that we kind of see with this kind of approach is that data engineers, they spend too much of time managing this kind of pipelines and ELT flows, right? Constantly, they need to communicate with the different stakeholders, like the business people who are producing the data at the first place, and the analyst or the data scientist who is going to use that data. So they're kind of just in the middle, and just trying to balance it out. And often they might just turn out to be bottlenecks. From a consumer point of view, they kind of lack a self-service experience to analyze the data. They don't have a way to get the required data whenever they want to, right? They have to rely on the expertise of the data engineers for every single data-related task that they want to do, right? So the time to insight process is kind of huge. But most importantly, all these issues that kind of that we see is also organizational, and that's where we kind of bring in this new paradigm like data mesh. So what data mesh basically tries to address is that it breaks that monolithic and single rock piece and kind of assigns the ownership of analytical data to each and every domain or the business unit, whatever you want to call it. So what we are basically trying to do here is trying to shift the responsibility of data creation, transformation, management, and sharing those data to every domain instead of just one centralized IT team kind of catering to every request they want to achieve. So every data stakeholder in a domain now have more ownership on the data to be at a global level. So for example, a data engineer can now just focus single-handedly on developing a self-service infrastructure platform, right? Which can be easily adopted by each and every business unit or each and every business domain based on their requirement. For example, if I'm going to run a business intelligence report, I might, just select from the right set of tools that I have from the self-service platform. If I want to build a model, and want to use something like Spark, I can use it from the self-service platform. So business units and domain have the responsibility now to create and maintain that data, and also treating the data as like a first-class product, and bringing in that mindset of treating data as a product. And most importantly, for the data consumers that we were talking about, that we now have faster and kind of easier access to the data, right? So data mesh for data architecture. Let us try to first demystify a few things about data mesh and kind of set the motivation string. So people often confuse about whether data mesh is kind of a new type of architectural approach, or it's something like that compares with all the existing architectures. In general, we have seen the evolution of architecture from data warehouses to data lake to data lakehouse now. And often people confuse it with to be a technological form of approach. Well, that's not actually true. And data mesh is not actually a new architecture or a technological part, but it's more about complementing the technology and bringing a paradigm or kind of approach that lets you deal with the data in a more, more agile way, in a more efficient way. So for that matter, data mesh can be applied to any form of data architectures, whether it's a data warehouse, data lake, or data lakehouse. However, there is a huge benefit on applying data mesh strategy to open data architectures, specifically on open lakehouses. And we will see in the next few slides as in why that makes sense. But before we go to that, first let's try to understand what's open data lakehouse, right? and what exactly is open in that open data lakehouse. So as the name suggests, and we can make a guess, and we have been reading and writing about it, a lakehouse architecture basically combines the approach of a data lake and a data warehouse. So it's not just a mere integration between the two, but the idea is to bring the best of the two architectures. For example, we can have the reliable data management features that we have in a data warehouse, right? But at the same time, they can be super costly, and we have the option of low cost cloud options like S3 or ADLS, some kind of a data lake that is in cloud. So, and why specifically are we talking about open data lakehouse? That's because the main reason behind an open lake architecture is the data is stored openly, and that's like the huge aspect of this, any data architecture. So as long as we're able to store data in an open format, like in form of raw files like Parquet, or like have a top layer on top of that, like a table format, that kind of gives us the agility to use and bring in any kind of engine that we want for any kind of task we want to achieve, right? So as you can see in this diagram, in the extreme bottom part, we see like the new data coming in, into a data lake, right? And data is stored in open file formats like Parquet, right? But we also have, we want to bring another like layer on top of those files, just to be able to manage those files, so that we can have those data warehousing capabilities that we were kind of talking about, right? All those kind of like schema evolution, just making sure we can do those DML operations, or just do time travel and historical analysis. So how do we get that into a data lake? Is via this kind of table formats on top of like those file formats that is stored openly. So table formats like Apache Iceberg is something that's kind of like truly open, and that kind of allows multiple engines to use and work on the same data at the same time. So for example, you can use Spark for some kind of like your ad hoc SQL, or Dremio for some kind of low latency SQL, and Flink for streaming. So it kind of gives that agility, like to like based on your use case and based on your requirement, it kind of gives you the flexibility to use the data, use the engine that you want. Because the data is open, you don't have to really worry whether it's locked into a particular vendor, whether I have to move it out of the system or something like that. So this gives us added advantages in terms of like running other workloads like machine learning, for example, right? I mean, now we store the data in open formats in the data lake. We dumped all the data, but we can also use since everything is open, we can use other workloads like machine learning on top of that. And finally, you have a top layer, which is like the app layer, which all the apps that you kind of consume, or the reports that you kind of consume from your BI apps and like Tableau, or like or even from data scientist perspective, you can use Jupyter to get access to the data. So data mesh and open lakehouse. How I try to see is that I try to see these two kind of like, one is a paradigm and one is kind of like a technological approach and architecture. I try to like understand like how they complement each other in a way. So and ultimately the whole idea behind like data mesh is to like deal with kind of scalability problem that we've seen with modern data architectures, right? So if we go to the crux of the problem, the scalability is one of the main issues, and that's why we have things like this. So data mesh usually works best for like for large scale analytical solutions, but at the same time, a lakehouse architecture is also like kind of dealing with the same scalability problem, but from a different perspective, which is more of a technological aspect, wherein you want to like have that ability to like scale your data, to put in different type of data like structured and unstructured or whatever you want to do, right? So it's important to note here that we cannot just solve all the organizational problem without just the right technical platform or the tool, right? Also, we cannot just have a right robust architectural platform without just bringing in those organizational principles. If we are not getting the mindset of how we treat data and how we pass the data from data producer to the consumer, it's kind of going to be a mess. So for example, we have seen and we have kind of like studied that decentralizing the data architecture won't solve all the problems that we have, or just adopting like Lakehouse as a technology won't help you succeed unless and until you have those measures in place. So ultimately, how I try to see is like kind of like complementing these two forms in each other, and that's what we are trying to achieve from this. So in terms of, if I have to talk about the four principles, I'm not going to like talk about the four pillars that we have in data mesh, but I think one of the main aspects that I want to touch here is that all the things that we kind of like achieve is more of organizational and technological, and usually it's kind of like a blend of both. So for example, domain ownership, it's an organizational aspect that every domain has the onus on the data, and we are trying to shift the responsibility of managing data and creating data products into each domain rather than a central centralized team doing it. But also it's technological, right? Because like you need an architecture to support that kind of mechanism, or you need an architecture to support building that thing. Similarly, data as a product, right? That the data product mindset is very important. Like it's very important to have that mindset, to treat something as a product, so that we can bring in all the specifications and all the standards that we set in terms of releasing a product. But if we don't have the right set of tools for developing the data products, then we will have a really hard time to be successful. So I think it's also the technological aspect and the organizational aspect that plays well here. The self-service platform is kind of like the only pillar that is rather technological than organizational, but also it involves like a lot of focus on having kind of like the right set of tools or infrastructure to support the entire strategy of data mesh, right? What we want to essentially have is one centralized data engineering, the data team, to be able to manage and provide a self-service platform, and each of the domains to kind of adopt to those kind of tools and platform and build on top of that. And obviously they can add new requirements and new tools as they want, as they grow, right? Federated governance is kind of same, which kind of like it's kind of like I try to understand as like a support system that kind of like we have data governance and everything that we're centralized initially, but we also want to let domain have that agility to that freedom to be able to set those principles, right? But still be able to adhere to that global principle. So we still want each of the domain to exercise their own kind of local principle, but keeping in line with those global principles. We just want to make sure. So Open Lakehouse is the platform to support data mesh, right? I mean that's kind of like the hit topic, like that kind of like I'm targeting right now. So we have gone through what kind of like an Open Lakehouse is and how it can kind of complement a data mesh strategy. But now let's try to understand how an open data lakehouse platform like provides an easy way to actually implement a viable data mesh strategy. And obviously these strategies are going to be different for different size of organization. It can vary a lot in terms of how big an organization is, whether do you really need a strategy like a data mesh or something like that, right? So as you can see in this diagram, it's basically some kind of a representation that I kind of like have visualized it, is that we kind of have that centralized team. We are kind of shifting from that centralized architecture to that domain-based architecture, right? Which is like the first principle of data mesh. So you have like, these three different domains here, like the marketing, sales, and product. And, the responsibility of now creating the data products is on these domains. And these domains are responsible to be able to like, create this data products, but also be able to share them within different domains. Otherwise, what's the purpose, and how are we benefiting? It's already going to be duplication of efforts. So now, like I mentioned in the previous slide, abstracting the infrastructure part is one of the like, main, part for a data consumer and, for the business users to be able to like leverage those benefits, right? And providing the necessary tool to build a data product is super critical. We cannot have like a great data product or, be able to share the data product for that matter, even if we do have the right kind of set of tools. So that's kind of the third principle I kind of like initially, touch before I go back to the data product part, where you kind of like treat Open Lakehouse. And that's kind of where the Open Lakehouse kind of comes into the play and makes things easier for it. Since with an Open Lakehouse architecture, you have like an end-to-end kind of data platform where you have all the tools. For example, you might have your like storage as your S3, right, as a data lake. And you might have your, file stored in Parquet or like Iceberg, like table format. And you might have different engines like Spark or Dremio or like, different kind of like tools like Tableau or Looker or Jupyter Notebook, like, being able to like use that kind of self-service platform. So coming back to the point where we are trying to like let each domain have that onus and responsibility of creating data product, it's important like each domain that have the right set of tools, right? So for example, in this case, let's say the marketing team, they have like their own domain. Now they see that, there's the self-service data platform. What they want to do is they want to create their own data products now. So what they can do is based on their requirement, if they want, for example, if they want to like, they want to like, use the data product to be like used by some other team, for example, like the sales team, which is kind of like an interoperability part of data mesh, right? So what they want to do is they want to like, use a compute engine like Dremio, like to, create a data set and, share the data set with other, different team. And they also want to involve like a tool like Tableau to like, visualize this report and be able to share the report. So what they can do is, they don't have to like select the entire set of tools from the self-service data platform. Whatever tools they require based on their requirement, they can just adopt from this self-service data platform now easily, because like the Open Lakehouse platform enables that way, right? And in the future, if you have some new requirement coming in, like for example, like, okay, today I'm doing BI, but I also mature and I want to do some predictive analytics and machine learning. So what I can do is I can also select the right set of tool from the service platform, or like, bring in something that is kind of like new based on my requirement, right? And finally, each of the domain, like there is a globally defined policy that kind of like the organizational wise have defined that there is a policy, but each of the domain has their own flexibility, like, in terms of how they kind of define, and, for example, they might have some kind of catalog, that kind of manages the data, and how they kind of share this data, which kind of governance policies apply, which kind of team are eligible to see this particular data product, right? So now that we have implemented all the 4 pillars of kind of like data mesh that we see kind of with the domains that we kind of distributed, we have a self-service data platform, we create data product, right? That's kind of like the main goal. So each domain now can create their own data products and make them interoperable. So for example, like I was talking about the marketing team, who can now create a data product called like webinar attendees, right? And what they can do is they can use the data that is there in the S3 data lake and store it in like open file format like Parquet, or for that matter, use an open table format like Iceberg. And now in the sales team, they need to use that product or that data set. Their domain's compute engine, for example, like Spark, can directly access the data which are stored in the open file formats like Parquet or like open table formats like Iceberg. So they are no longer restricted to like just being, restricted to a particular vendor, and everything is open, and they can just, interact with the data based on the governance policy and everything, and they can use it for their own needs. And all of this is done while respecting the global governance policies that we have. So to sum it up, the benefits that we kind of see with, ultimately the whole idea was to basically show that data mesh is a strategy in general. It's a basically an organizational kind of paradigm that kind of streamlines everything for an organization that is kind of maturing, that has like, a lot of like data sources coming in. It's kind of like, it's a huge analytics project. So I think one of the main idea here is like the scalability perspective. We want to deal with the aspect, and Open Lakehouse from a technological perspective, it kind of like is designed for that purpose, and data mesh that kind of aligns and complements that kind of architecture, right? And since data is open in an Open Lakehouse, architecture, sharing of data, consumption of data between the different domain teams, it kind of makes it easier for it. And also, like I said, like the self-service platform that we were talking about in the previous slide, it kind of like facilitates a kind of standard set of tools. Even though, like as an organization, you might have different vendor policies, you might have bought in different set of tools that you want to kind of let different domain use it. So it kind of standardizes those set of tools and abstracts the infrastructure. So for example, if I'm going to start a new domain and I'm going to like use some analytics in that domain, I don't really need to like start creating and developing my data infrastructure from like scratch. I can just adopt to whatever is there from the Open Lakehouse platform. And also it makes the platform future-proof, right? Like I was saying, the new use cases that you might have. Today you might be doing BI, but then in the future you might also like want to leverage machine learning. So what if you want to use a new tool in that particular scenario? How do you like deal with that? And that's one like kind of like one huge aspect. It kind of makes your data architecture future-proof that you don't have to really worry about. And also the open table formats like Iceberg, or like in general the open table formats that you see in top of the data lake storage that kind of brings everything together for a data lake house. It kind of helps manage the product, in an easy way. For example, like, Iceberg has metadata information, which kind of lets you like know, okay, we want to like, deal with this particular chunk of data at a particular point of time. And if you want to go back at a particular point of time based on our like, financial quarter end analysis, I'm able to do that based on that. So that basically brings everything together. And that is pretty much all. And like I said, like the implementation can vary from like, it's really more of an approach rather than implementation. Like, we also saw on the previous slide from Sven that implementation is a huge aspect of this. So I think it's more of an approach that can be kind of like trying to bring in, and, it depends, and it will largely depend on different scale of the team, different, conditions of the team that you have right now, whether it's really an approach for you and how you can benefit out of it. And I think the whole point through this, presentation was to show how you basically can complement a data lakehouse architecture with data mesh. I'm open to questions right now. Thank you.
Awesome, Dipankar. We have several questions for you. Okay, so the first question from Jacinta Morjes. I've not heard you mention the primary function of a data warehouse, and that it integrates data from multiple sources. Is this still happening in the Lakehouse prior to the data being pulled into each domain?
Yes, so data lakehouse architecture kind of like tries to eradicate that process of, ultimately the whole point with the data warehouse that we have seen is that you try to integrate data from multiple sources. But what the agility that you have with a cloud data lake, for example, like a storage, like a S3 system, is that you have the ability to dump everything on that particular data, and you don't have the fear of getting into a swamp, right? You're not just dumping data into the data lake, but with the lake house, you have the ability to manage the data. So definitely, it's you have the ability to pull in data from different sources, and we have different tools like to do that, like to put into the data lake house. And the added advantage here is that you don't need to worry about like what data, what you're putting in there. You have the ability to manage that using a table format like Iceberg.
Okay. Next question from Fernando Durante. To make this work, we will need a catalog or something to automate the data discovery, correct?
Yes. So data, yeah, definitely. I think I touched upon this part in the federated governance part as well. Like definitely we need some way to be able to show the fine grain kind of like what kind of people have what kind of access, right, to the data product, right, and data mesh strategy. Like you can assign different administrator to different kind of different catalog, different kind of source, different kind of data product. So it's very important to have that, the catalog. Definitely, it's something that it would be one of the tools I would assume in that open Lakehouse platform and in that self-service platform, and you're going to use that as part of your own domain.
Okay, and next from Michael Meyer, how are domains integrated and presented to business users to use the data?
So if I understand it correctly, I'm not sure the intent, but if I understand it correctly, is it in general, for example, if you want to in general have a integration between the various domains that we kind of divided in the first place, is that obviously we are going to make sure that the governance policies are respected. That's the first thing. But how do we present each of the use case or each of the analytical report? That's kind of the responsibilities on each domain. And ultimately, with a new data mesh paradigm, we have to come to understanding that we have different roles, like data scientists, like data product managers, data owners, who are kind of in this particular approach, right, in this particular strategy. Ultimately, they have to come together and be able to share it at a business level. So that kind of ownership on that particular role is very important in terms of data mesh.
Okay, next question from Narges Rokni. I want to ask if kindly would be possible to share with us a link in which we can see an example. That would really help to get an idea of how to think about defining the domain in data products. I would appreciate it. I guess for that one, Dipankar, if you have a good link, for example, I can include that on the blog post that will have the recordings and the slides.
Yeah, definitely. Yeah, I mean, yeah, definitely. Let's share some blog links. I'll be sure to include that. Thanks.
Sounds good. Okay, then from Fernando Mirante, again, we have a setting data warehouse equals greater than historical data, and then ask how will you do that with the data lake? So I guess basically organize historical data. I think is the question.
Right. I think it's more about the perspective that we kind of treat data warehouse in terms of the practices, we kind of treat them as a historical data, right? We want to see the aggregation over time or that kind of thing. But with a data lake, that was the problem, right? That we saw that we cannot do that. But with the lakehouse approach, by bringing an additional layer on top of the different files that we have, we are able to manage the historical data. We are able to bring that historical data in place. So for example, Iceberg has something called snapshot, that allows us to go back at a certain point of time, or segregate data from a particular period of time, and analyze the data based on that. So definitely that's a problem that I saw with data lake, that you cannot probably do that, but by bringing in another layer with the lakehouse, that kind of enables that approach.
Cool. Does from Sarfaraz Hussein, does each domain, like marketing, sales, need to be assigned dedicated data engineers from the central data team so that they can create domain-specific data sets tables and manage specific tool frameworks like Spark, Dremio, etc.?
Right, that's a nice question. Yeah, definitely. The whole idea is that so the whole idea behind the data mesh strategy, if I have to break down, is that the centralized IT team, who will be the data infrastructure engineers, the data engineers, they will be keeping their focus on the platform, which is the self-service platform. And then you will have individual domain will probably have their own data, analysts or data scientists, to create their own products and own report on top of that. You might also need to have some kind of data engineers in that particular team to be able to in some way transform the data or pull the data in some way. but ultimately the shift of responsibility is to that particular domain, rather than the centralized data team doing everything, and that they are kind of like swamped with this request that we see in general analytics environment, right? So definitely, we need the right roles and the right people to be in that particular domain who can use those tools from that self-service data platform.
Okay, next question from Mahesh Mathura. Where are data quality issues addressed by domains?
That's a good question once again. Yeah, and it's a responsibility of each and every domain that's kind of like the producing of their data. They are the one who, like, for example, like I said, like different roles are going to be part of this data mesh strategy. Like once, and as an organization, you have decided that we are going to go with a strategy like data mesh, it's also bringing all the roles at the same, in the same level, and making sure those responsibilities are aligned. So data quality perspective, it's also definitely the responsibility of the domain, like who are producing the data. But I would say it's also collaboration between the data producers and who are kind of like dealing with this data. For example, there may be some data stewards in a particular domain, like who are kind of responsible for making sure that those checks are kind of passed right before they go on to like being a full data product. So the whole idea behind having that mindset of like a product is to be able to like address those kind of concerns, like that we know that the data product is going to be of a certain standard and quality. So it's definitely the responsibility of the domain, but I would say in terms of the roles, it's also the data producer and the data product managers who are kind of like involved in that process.
Okay, next is from Jeff Plotz. Do you see a need to have a mature NDM and data governance baseline in order to enter the data mesh sphere?
Yeah, it's an interesting question as well. To enter the data mesh, like sphere, like the scene, that the paradigm, it kind of like, I would go back to Sven's kind of presentation. Like it kind of all depends on like what it kind of is difficult to align to like each and every pillar and say we are going to like be able to achieve every single thing. But I think MDM, like master data management and data governance baseline, is something that every like domain is responsible for, and they might have, but that's definitely not like one of the starting point like to enter the scene.
Okay, and the last question from Wahid Malik. Do you create a separate data pipeline?
I am not exactly sure what that means, Wahid, but like, okay.
Oh, I think it means like more like, does each domain have to create their own separate data pipelines to like ETL data into their product?
Right. So yeah, obviously, like the point here that we are kind of trying to eradicate with the open lakehouse architecture is that kind of like thing, which we are trying to eradicate from the pipeline. Obviously, we might need some kind of data. For example, if we have some kind of a data that is sitting in RDBMS and we need the data in any way in our architecture, we might need to like build that pipeline. But overall, the idea with the open lakehouse platform is to like be able to like store data in that particular like open format and be able to like work on the data directly, right? For example, like like a Parquet file or like the iceberg tables, we should be able to work on that data directly with an engine of our choice, like Spark or like Dremio, like and the whole idea is to kind of like lessen down those pipeline and be able to like deal with those failures in a more efficient way.
Cool. We actually, a few more questions have come in. So first from Dirk Clemens, how would a data mesh ensure a common semantic model to be defined if each domain designs their semantic on their own and in different speeds?
Right. If I like, I mean, semantic model, I'm not sure exactly what that would imply, but if I have to guess, I guess the question would be like, how do we come to like a common model and common understanding of how those design are made, or how basically the different policies are like the measures are implemented basically. So like I said, I mean, definitely we are going to have like a centralized data team who are going to be like, the whole focus of them would be like to be able to like design those and give those some kind of directions to individual domain so that they can easily adopt to those design guidelines or those semantic model that we want to have. And that kind of like, it's one way to see it, like how we want each of the domain to like act on their own based on adaptation. So, do you want to add something like?
Oh yeah, I was going to add. That's definitely a governance question, right? So, for instance, at the company, let's see, HelloFresh. Okay, HelloFresh implements like a large data mesh. They, for instance, say something along the lines of every single data product has to have like a column they're table-based, okay, like a column named customer ID, and this has to be there, so you can join different things together. I think it's that's kind of the idea of the semantic model, I hope. So that's a governance question where you say, okay, so this is kind of like how you stitch things together, and that's governance. It's very important, by the way, to mesh these different products together.
Right.
The next question is from Ahmet Orkun Osil. Hi, I have a question about the historization of data by formats such as Delta. Are we really sure that time travel-like features are fit for long-term storage? As far as I know, it is not designed to keep years of history, but relatively really short periods similar to flashback queries.
Yeah. Alex, do you want to take a dive on that, or like?
Oh, sure. Basically, yeah. I mean, I would generally agree that generally if you're going to be using Apache Iceberg or Delta Lake or Hoodie, you are generally like you're not preserving years and years and years of snapshots. So like storage would get a little crazy, but you still probably would have like like other types of maybe snapshot tables or whatnot for like a longer term period. So you might make like a monthly like a monthly replication of a table or a yearly replication or something, like some sort of regularity you can keep separately. But again, it also comes down to like concerns about like regulatory governance. So some data you're not going to be able to keep that long because you have to deal with things like GDPR or whatnot. So it just depends on what your regulatory burdens are, how much data you really want to store on your cloud storage, and how far back you want to go. You could go long term with using any of these table formats, but I don't think that's going to be the general practice. Generally, probably for like longer term storage, you'll have sort of like alternative copies or materializations of the data stored in some other way, depending on sort of the SLAs and needs of that particular table or firm.
Right, and just to add to that, like based on my experience of whatever I've seen, is that it all depends on the organizational policies of how long you want to keep the data, based on like what Alex mentioned, like based on GDPR or something like that. But it definitely allows, like for example, like Iceberg or something like that. It definitely allows you to like time travel to a longer period for sure. But it also depends on the strategy and how long your organization is kind of like doing that. So I think that's kind of something important. Yeah.
Got it. Okay, next question. This is a follow-up from Wahid Malik. So basically, going back to the separate data pipeline. So the question here is like, if that's the case, like, don't we end up moving to ELT, export load transfer, versus the traditional export transfer load ETL?
Yeah, I think it can shift to that. I mean, like depending on like how I basically have worked is like in terms of data warehouses, that might be a more ETL might be a more better approach, because like we have to like come down to a particular particular semantic model or like particular hierarchy of the schema, right? But when we are kind of having that agility with the Open Lakehouse platform, we can go from that shift from like ELT to ETL. But obviously the idea is to like be able to like not just focus on the extract those pipelines, but just be able to like developing those products based on the platform that we have in house, because we are going to like store data in an open format, which kind of gives that agility, right? I mean, ultimately it boils down to that point.
Okay, next question is from Tianlong Fu. What if two domains need to exchange data?
Yes. So if for example, in my slide, if I want the marketing team to like be able to like work with this, they have developed a product which is like webinar attendees, and they want to share with the sales team, what they can do is in one of the way like that I kind of showed is that they can have the data stored in like Parquet, or for that matter they can use just a table format like Iceberg. And what they can do is, since this data is open and Iceberg is like allows multiple engines to work at the same time, I would assume a compute engine from the sales team would be able to directly interact with the data that is already open. So you don't have to worry about the interoperability part. We're kind of like solving that issue as well. How do you share the data, given that you are not going with any kind of microservices kind of architectures?
Cool. Okay, so then this final two-part question from Jacinta Borges. First, I'll read the first part and then the second part. So it appears that what makes a data lake into a data lake house are the specific tools that are used at the tool layer on the lake. As such, it seems like it's really just a data lake with user tools. Since there is no longer no single version of the truth, as such, you're going to have the same old problem of siloed data, i.e., the same question can result in multiple answers depending on the various domains' perspectives.
So what basically what we are trying to achieve using a data lakehouse architecture is be able to kind of like we are not limited to a particular set of tools, right? What we are trying to achieve here is that we have a a data lake platform, and we were kind of like historically we were dumping data in that platform just to be able to achieve those different workload goals or like machine learning or unstructured data goals, right? But now with the lakehouse architecture, when we are bringing an additional layer on top of that, we are kind of eradicating all those things. We are trying to manage those files so that it doesn't ends up in kind of swamp or those kind of issues that we kind of see. So I would assume that single source of truth, it still remains the same as the data lakehouse. So the data lakehouse as a platform, as an architecture, is obviously brings a set of tools. I would say there is the compute part, right? There are different compute engines, but then there is the storage layer, and there is this data infrastructure part, and then there is the different ingestion tools and something like that. So definitely the data architecture, the lakehouse platform, what it brings to the architecture is a set of tools, and it allows you to have that end-to-end data kind of platform experience for all your data engineering, data science, or data analysis needs. But definitely it's going to have that single source of truth. And we are making sure with the lakehouse architecture that we kind of align to the single source of truth, right? With that table format on top of that. It's not just a data lake.
Cool. Dipankar, do you mind if I add just one little detail to that?
Yeah, for sure. Yeah.
Okay. Just one other point on that is yeah, you should avoid the whole siloed data thing, long as there's some basic fundamental agreements, particularly on the table format going into the data mesh. So long as every domain and every product, they're all agreeing that they're going to use either Iceberg or whatever table format, then the idea is that pretty much most tools should be able to connect to that format, and it should be easy to exchange and work between the different domains, regardless of how they structure their data. Having that sort of common table format really allows you to use several tools in each group to kind of decide what tools you're going to use and still be able to connect to that data and work with it. So again, like Dipankar was saying, that data lakehouse, if you agree at least on those fundamental pieces like file format and table format, if those are all agreed upon going into sort of that decentralization, then you shouldn't have you shouldn't have the issue of siloed data, because you're not, even if you have using different tools, the data is in a format, are in a file format and a table format that all the tools, regardless of which team you're using, can speak to.
Thanks, Alex.
That's the last question. So again, I want to say thank you to Sven and Dipankar for presenting. Again, make sure to follow them on LinkedIn and follow them on Twitter. So that's Sven Balnojan and Dipankar Mizumdar. And and then also make sure to check out Subsurface Live, our conference that'll be next March. And again, if you want to submit your talk, head over to dremio.com/subsurface/live. And you can submit your talk and sign up to be updated on the conference. We should be having one more meetup before the conference, so do make sure to check in on that. So we'll probably be announcing that over the next few weeks. And the recording of this should be posted within the next week or so. I'll try to get the blog together over the next day, but it'll be a blog that'll have both recordings for both talks and the slides. So keep an eye out for that. You should get an email once that becomes available. So keep an eye out for that. But again, I thank you all for attending. We always are glad to have you here at these Subsurface meetups. Have a great day. And again, thank you one more time to Dipankar Mizumdar and Sven Balnojan.
Thank you, everyone.